we will be revising ourselves on our capabilities. We'll be revising ourselves. We'll be revising the things that we know already how to do, so that we know about our capabilities, we know about what we do, we know about what we are capable of. So that's something I feel very important. So today's session, that's what we'll be focusing on. Like, I'll be learning from you guys. Instead, I'll be using most of your work uh, anonymously. Like, I wouldn't take the name who did what, right? So I'll not you know I'll not spoil your name as per se, but I'll be going through your work to dive deep into the things that we already know how to well do it. So there is nothing new that we will be talking about today, but we will be mostly be working on things that we already know and see how we can make things work out that way and learn about our own capabilities. Okay, so if you guys have any questions, if you guys want to recognize yourself, hey, I did that. If you want to hide, it's okay. I won't be showing anyone's name. I want to keep it silent, except for one person, because that person showed his face. I cannot hide that. But for others, like, I'll be hiding your name so that nothing comes out. But if you want to recognize yourself, feel free to raise hand. Nisha will call your name and we can interact. That should be fine. Uh, so what we'll be talking about today is the most important thing that we do at Spiralogics, that is solving problems, building solutions, right? So problem solving, what is problem solving, right? So that's something that we do every day in our personal as well as professional life, right? So problem solving is one of the most important and crucial soft skill that all of us need to have to succeed in anywhere, be it your personal life or professional life, any industry, anywhere. It's very, very crucial. And especially in our field, it's very, very critical, because if we do not know how to solve problems, then we do not belong to this industry, because our industry, this industry particularly about computer science, is all about solving problems. So we'll be talking very deep into the problem solving skills that we already know. So problem solving is actually a process of achieving a goal by coming across its obstacles, analyzing problems, and finding a solution to reach to a common objective. All right. So that's what we'll be focusing on today, and we want to focus on some of the foundations of computer science and mathematics. Not that I'll be going into very much details. I'll be talking about only the things that you guys already know, right? So computer science is one thing that I want to clarify is computer science is not just about computers, right? So yes, it has in its name itself, it has computer on it, and we use extensively to as a tool to solve our problems. But computers are that's about it. It's a tool, right? That's a tool that we use extensively to solve our problems. So computer science is not about the computers. It is actually about solving problems. It is about study of the problems, and it is about the solutions that come out of this problem solving process, right? So as a computer scientist, like all of us, since we are in this industry, all of us know what we do, right? So our job is to create the step-by-step instructions to the computer or a server to provide a solution to certain problem, right? That step-by-step instruction is algorithm, and the pillars that the algorithms depend on are data structures. So, those are the basic foundation. That's what computer science is all about. It's all about solving problems. And same with mathematics, right? So many of us like get bogged down with the formulas. Like, uh, many of you proudly say, I've heard it many times, hey, I'm bad at maths, I'm not that good in maths and all those things. But it's okay, because that's how we were taught. We were bogged down into our formulas, geometric drawings, and all that we forgot the foundation of mathematics. But mathematics, all it's teaching you throughout your process, if you notice it, is it's teaching you the process of solving problems. If you guys have noticed, in any exam paper, like if it's a English paper or a science paper or social studies paper, the questions will be like answer these questions, right? Answer, choose one of the following answers, or these like that. But in maths, they will say solve these problems, right? So math is all about solving problems. It's not about you knowing, hey, what is sine squared theta plus cos squared theta, right? It's okay if you know sine squared theta plus cos squared theta equals to 1, because that's one of the tools you have handy in your pocket. But the important part is, how did we figure out that the squares of the sines and cosines is an identity, right? So that is the most important part, is how we solve that problem. So that's what we want to focus about today. Is like I see like many of us, especially the developers and the QAs and many in our field, we get bogged down with so many new technologies, right? So we are learning about machine learning, we're learning about AI and all that. And that's a great thing, right? We need to do that. We need to learn new things every other day. I do that myself as well. So, but we are so much bogged down into these new things that we sometimes tend to forget the foundations of all these, right? The foundation of all these things is all, it's all about solving the problem. So that's what we want to focus today, is about the basics things, like the smallest of the smallest things that that impacts in solving problems. Now we'll be touching base a little bit about how we as Spiralogics have been in the building solutions. We take a real pride in calling ourselves, what is Spiralogics? If anyone asks you, right, it will especially be important for new guys, because you are new, you might not know. But if anyone asks us what is Spiralogics, our answer is very simple. We say we build solutions. We do not say we code in Java, we code in Python, we code in C sharp, we code in JavaScript, or any of those. We say we build solutions. We take real pride that we build solutions. It's not about coding in this language or that language or anything. Like, we will code in any language that we feel it as necessary. It's not like, hey, you give requirements ABC and we give you ABC. No, what we'll do is, from our customers, we'll understand the pain points. We'll understand what they are facing problems about. We'll understand their problems. And we'll understand their problems, we'll analyze their problems, and we will come up with the most feasible solution that will work out for them. And this is the most important competitive advantage that makes Spiralogic stand out amongst our competitors, right? So that is all we about. Like, all the departments, not only the developers, QA, BAs, PMs, DevOps, comms, right? Like, everyone is all focused into one and one thing only, that is how to solve a problem. We are problem solvers. We build solutions, and we take a real pride in that. Our customer from day one is still with us, doing new projects every other year, right? So that's a real pride, because why do they like us? Because we are not only coding for them, we are actually providing them with the solutions for their problems. And that is the bottom line, and that is the most important part about Spiralogics. And that's what I want to revisit a little bit today. So these are the things that we will go in. So for that, what we did, we asked a simple question: how to make tea, right? So we devised a simple design experiment. So during COVID times, we held many different virtual activities, right? And our communications team was excellently well on that. Thanks, Nisha and her team, for doing those great, because on our COVID days, we were so bored sitting at home that these virtual activities were like, so fun to be part of. Now, not so much, because we can go out, right? But anyways, during those days, we made one small design exercise. What I wanted Nisha to tell me was, okay, I do not want to be part of this experiment, because I do not want to know the names, right? So I want to do this study without knowing the identity of who did what. But what I want to do was, I wanted people to solve a problem that everyone knows how to solve. And she came up with an idea, says everyone knows how to make a tea. All right, then that's great. So let's ask everyone, hey, just put down in the paper, just write it down, how to make tea. And She did that, and as any design process, it seems very trivial at first, but on deeper inspection, it tells a lot about the way we solve our problems. Okay, so many of the slides that you'll see after this will be your work, the submissions that you made to our communications team, and we just wanted to know, how do you guys make tea? That's something that we all know. And, uh, and many of us participated. I'm so glad, like we got so many interesting submissions. It's really interesting. So let's dive a little bit more into those. Okay. All right. So many of us, so this is one of you. If you know who you are, like I don't know who drew this, but whoever drew this might be watching this right now, right? So most likely will be watching this right now, but I don't know who that is. But many of us drew something like this. Is we drew a process of how to make a tea. Like it's very simple. Collect the ingredients like milk and tea and those things, and oh, this person was even like you know he or she even included like this, what are these called, luangs and sukmels, right? I don't know what they are called in English. I think this is clove, but sukmel, I don't even know the English word for it. But he or she is very interested in making her tea very spicy or flavorful. Great. So collect your ingredients, mix them up, boil, and ready, right? So many of us drew like that. So, and once it's ready, and voila, like it's happiness and enjoy, right? So it's morning time, everyone. Like, so you, many of you might already be with the cup of tea, sipping your tea, looking at me. I know, like I understand, that's completely fine, no problem, just relax and enjoy. And many of us drew like this, right? And some were nice illustrations like before, like very common, right? Previous drawing and this drawing, if you look at it, very common, like collect stuff, mix them, boil, and ready, right? So many of us submitted like that, drew like that. Some with like even colorful, like someone with the artistic mind or something. Even her tea is wavy if you look at it, right? So so colorful drawings with the clock, like how long you have to boil and all that. But this this was tea leaves. At first I thought, like, why would he or she put the matchstick on this? Like I thought it was a matchstick, but but it was a great drawing. And there were a few like they that like we asked just draw how to make tea, but some even went with descriptions. That's fine, that's completely great. They add a step-by-step descriptions of how you make a tea, how many cups of milk to add, how many minutes to cook, and all that, right? So great stuff. Like I don't know who did that, but whoever did this, great job, great job. All right, this is awesome. This is really fun to look at. And some of us were even more creative, like like this one was really interesting. When I was analyzing this, I was like, man, like this guy cooks tea in a bonfire, like with woods and stuff. Like we are in modern age, like we don't cook in woods anymore. But hey, he prefers that. Maybe he wants to a bonfire to make a cup of tea, right? And his tea is spilling. Look at that. Like, and this is something that I was really like, because very few drew this. Like I think it was only one or two who drew like a spilling tea. uh, but as we know, tea spills most of the times when we make one, right? So it was very fun. And some of them were like mathematical and flowchart type. So like they were, and it explains pretty well, like, hey, just get a cup of water, cup of milk, add tea to it, add sugar to it, add, and then you put it on gas at fire, and boom, your tea is ready, right? Very flowchart type and awesome. This is great. This is great. Good stuff. If you guys want to say, hey, I did that, feel free to say so. But just to say, I do not know the names of the persons who wrote this, but I was really mesmerized by the ways that you presented how you make a cup of tea. And some of you were very detailed and very descriptive. like you wrote down into the details of how you make the tea, like you know, this person actually wrote like paragraphs on each step, which is great. Must be our one of our business analysts. Like if you're not a business analyst, whoever wrote this or this, like if you're not a business analyst, you might want to think your career on business analysis. Okay, this is what you need. Like that's what they do, right? Like take a small thing and explain a very long, right? So this is awesome. Like they put a lot of descriptions and details into it, which is really really awesome. And some of us were even systematic and algorithmic. Like maybe these guys were are developers themselves. Like this one is like almost a pseudo code, right? So they are like writing step by step, right? Okay, have exactly this much of milk, this much of water, this much of tea, right? So very systematic. And some of were like specifying, okay, these are the ingredients and equipments. See, these are actually data structures if you look at it. So the persons who drew this, they have a very creative mind to understand the data structures and algorithms very properly. Like I was like, oh wow, these things are good, and some of us even went further. And I don't know who drew this, but they even made a marketing pamphlet. So someone drew this, like this one is like as if I'll go out and put up in my website, hey, this is how we make a tea, buy from us or something. It's so attractive, very attractive. Like I really loved it. Like I keep on looking at it. Whoever draw this, like it's really awesome. Like we should get you in our design team or marketing team to make some PowerPoints or marketing pamphlets. Like, this is awesome, right? So again, like steps detailed and with diagrams. It's really awesome, like marketing pamphlets, like how you drew that. And some of us even went a step further. Like I don't know who did this, but like some of you even went a step further. I asked for a very simple thing. I asked like, just draw how to make tea, right? And they were like, okay, we'll go one step ahead. So they decided to make a video out of it. Like, fine, I did not ask for it, but hey, but cool animation. Like add some hot water, mix your tea bag, add some sugar and warm milk. Very true. And boom, animation, and your milk tea is ready, right? So cool animation there. Whoever did this, thank you, guy or girl. I don't know who did that, but it's awesome. It's really I really enjoyed it. Some even made a story like, okay, so algorithm in a video. So they made a video out of it. And this person, like wants to make the best tea in the world, wants to carry a fire extinguisher if you catch a fire or something. Okay, so and he wants to go all the way to the farm and all the way to the cow to get a milk. And after that, I think he or she got lazy and like, oh man, like I'll include 5 to 9 in one slide, right? But this one is awesome. Like it goes beyond, right? He or she is thinking beyond just like, hey, if I want the tea, I need tea leaves, but where do I get the tea leaves from? Let's go all the way to the tea farm. I need milk. If you don't have the milk, go all the way to the cow to get your milk, right? That's amazing how you do that. Like amazing stuff. Now we have one more that I would like to show. The one more video. Now before I run this video, I would like to. This one has audio on it, and yeah, for some reason it's a lot louder than my voice. So I think it's better if you guys drop down your volume to like 60 or something so that it does not burst your ears. But this one is very interesting. This has nothing to do with our study. It did not contribute much to our study anyways, but it's very fun. Okay, so for comic relief, I would like to show you this, and it's very fun. Let's just watch this video. Somebody actually, I just asked how to make a tea, and somebody actually made a story out of how to make a tea. So let's watch this story real quick. Lower your volume if you have not already. Okay.
Snap back to reality. That's not I'm not just no,
Oh, dear honey.
दुधको या
All right. So it was really fun, and this is the only submission that I know who made it. All right, because I could see his face. Um, but it was really good. Like his way of solving his problem is make somebody do solve his problem by giving him or her some money. So he's basically playing mine or Samir's role. Right. So that was a very fun video, and many of us might even recognize. For those who don't understand Nepali, I'll just explain. Like, you might have already understood what he was doing there. But basically what he was doing was he was having a nice date with this girl, and had a nice cup of tea and all that. But that was just his dream. In reality, what he does, he goes to his mom and asks, hey, can you make me a tea? Like, oh, I don't have milk. Then he goes out to the tea shop and gets the tea by paying some money to the tea shopper, right? And that's how he makes his tea. All right. So that is a very creative way of saying how you make a tea. That's one of the way to solve the problem. And I'm really excited to see, like, our guys are creative enough to pull that off. All right. So thank you everyone for this participation. Like, I thoroughly enjoyed going through each and every one of your submission. I could not include all of them because of the time constraint. Like, Nisha gave me only 1 hour and 15 minutes for this, so I could not show all of them. So if I could not show some of yours, sorry, but like, I would really like to say I really, really thoroughly enjoyed your submissions, and they were awesome. Every one of the submissions illustrated the creativity that each of you had. Like, your creativity was bursting out in each of your submissions. So thank you very much for your participations. Please give yourself a big round of applause, at least the virtual one, right? For your creativity and all those things. Very impressive job, guys. I really learned a lot from you, and, like, it was amazing. Thank you very much. Claps to all of you. Claps to all of you. All right. Now, now the real thing. Okay, so the fun part is over, guys. Okay, so the fun part is over. Like, it was so fun looking at those diagrams, looking at those videos. It is just amazing. Then I went into the next step. Then I asked myself, what's in common, right? It's time to analyze these submissions, right? The first thing, let's pose the first thing, is what's in common in all of those, right? So can you think of anything that's in common in any one of those, right? So every one of those, like, it shows how intuitive we are, how intuitive nature we are. And upon the deeper inspection, we can find many things that are common in them, right? So that's the first question that we posed, is what's common in all these. And the first thing that I would like to bring out that I found in common is all of these submissions, if you look with the deeper inspections, is all of those had nodes. So nodes are basically the tangible objects that represent, like, things like, milk, tea, your ingredients, your spices, your kettle, equipments like kettle, gas stove, or whatnot, right? So all of those, so all of them had nodes, and all these nodes were linked by links. So all these submissions, like, they were so unique. Each of those submissions were so unique from each other. You guys saw some had videos, some had like diagrams, some had like words, some had diagrams and words. But one thing that's common in all is that every one of those had nodes and links. Like, every one of those had, like, these are my tangible objects, and this is how I go from one node to another. All right. So nodes and links were very common. And some of us, it was represented directly. Like, if you look at this diagram, if you look at this, you'll say, hey, there is no arrow. Where is the link? Right. But in a way, like, they are representing the arrow with the use of the numbers, right? So with the use of the numbers, they are linking. One is linked with two, two is linked with three, three is linked with four. So that intuitiveness, unknowingly somehow, like, the person who drew this might not have thought, like, this is how I'm linking it. It just came intuitively, but it's one of the ways. But this is a link. It's linked between the nodes. So all these screens have links and nodes. And this also shows one of the interesting things is the cultural bias that we have is, since all of our submission is from, like, from Nepal, India, US, from in our all our culture, what happens is things move from left to right and top to bottom, right? So if you look at this, it goes from left to right and top and bottom. So it came as like, very intuitively, it came as things go from left to right or top to bottom. But if you are from somewhere like Pakistan or, Saudi Arabia, for them this will be difficult to understand because for them it goes from right to left, right? So some of those cultural biasness automatically comes in, which is great. Like, I was like, man, this is good stuff. While being different from each other, all these diagrams had nodes and links, right? So this is like universally common, and this combination of nodes and links, it what represents a full system model. So if you look at this, so okay, so this is actually a full system model. The nodes and links, it makes a full system model. And the system model, what is a system model? System model is basically our private mental model that we represented. Like we were thinking and we represented our thinking into paper, right? This is a typical definition of uh, system model. And it was common in all. Okay, not even a single person missed the having nodes and links. Like this person had like steps, right? And all the descriptive and all that. Link, the nodes are the descriptions, then the steps are the links. But it also shows our preferences. It also reveals our points of perspective. Now, what nodes does is it reveals our points of perspective as well. For example, this person, he or she is so much interested into, like, he or she wants her tea to be very flavorful, right? For him or her, ginger is as important as sugar. Okay, having aroma and flavor to the tea is important, right? So we know their perspective. We know their perspective. Their perspective about tea is not just having a sip of tea. Their tea gotta be awesome, all right, or gotta be like flavorful with aroma. Smell is important. The taste is important, right? So it reveals our perspective, right? And in the similar way, like for this guy, if you look at it, like the same thing, we have nodes and links, steps in there. So, but this guy, like, say, he or she put gas in there, written down. He did not write down kettle. He did not write down like other things, but he wrote down gas and with even the fires on it. So what it's showing is his perspective for him or her. It was important that, the source of energy is important. Like how do I heat is important, right? Many of us might even have missed, but that each drawing had its own perspective on the same problem. So it was, all of us had the complete system model utilizing nodes and links. That is one of the most crucial skill that we need to have. And just be happy that, like, we did the study, not even a single person lacked this skill. Okay, so we all have this skill, we all have this intuitive nature to put the problem into nodes and links. These are my nodes and how I link between them. That comes very intuitively to us. That is where the algorithms begin. That is what algebra taught us, right? That is what mathematics taught us. Now, even after drawing those amazing node and link structure of system models, and if you tell me you're not good at algorithm or you don't know algebra or you're bad at math, then I say, I don't believe you. I would use another word, but what I'm saying. So what I'm trying to say is it's great. Like we are very intuitive at this, but sometimes we tend to ignore. It's so intuitive, like we tend to ignore until we are told to, right? You guys drew this because Nisha told you guys, hey, you guys need to draw how to make tea. But when you make actual tea, you don't go and draw, right? Because it comes so intuitively, you don't draw. But what I'm saying, but what I'm trying to say is like when you're solving complex problems, like at work, in your professional life, or even in the personal life, if you're having complex problems, the first thing you do is draw. Do not care how bad of the artist you are. I'm a very bad drawer, no problem. Like, but I will draw. Like we saw the illustrations, like they were good. I wouldn't say from the artistic perspective they were great, but you drew, and that's where the system model comes in. So put your mental model to paper. That's the number one thing that we have to put. Keep, just draw, right? Your system models intuitively comes up. This skill is something that all of us have. All of you guys, as especially if you are in Spiralogics, you must have this skill, because you will not be in Spiralogics if you don't even have the skill. And as the study proves, all of us have it. That was one thing that was common in everyone did that. Everyone drew the system model. Everyone drew nodes and links. Everyone drew. So please draw your mental model to paper. Okay, so that was the first thing that was common in all. Now moving on to the next one. What was common amongst others, right? So for that we did a little bit of analysis, and so after we have nodes and links, then we just said, okay, so how complex is the problem, right? So the complexity of the problem is defined by the number of nodes or number of steps, right? Same thing. Uh, uh, you know, how many steps do you take to solve the problem? And if you look at it, most of us solved it in 5 steps, right? So it ranged from 3 to 8, pretty much, right? So, and that was another thing that really mesmerized me is like, all of you had that mental uh, capability to think that the system model is best represented between 3 to 8, right? I know you guys did not think about this thing when you were drawing that, but that is true. Like, various researches and studies have shown that if you're representing your mental model, keep it between 3 and 8. And actually, especially three. Three is a magic number. All right. So if you can represent your mental model in 3 blocks, like, that is the most easiest way for to convey your message. That is what people will understand. Okay, because 3 is the first number that can make a pattern, right? So 3 is used everywhere. That is called the power of 3, right? So the 3 is amazing. Like, that's why you'll see all the catchy slogans like yes we can from Obama, just do it from the Nike, or like, many other slogans will be like in 3 syllables, right? They will be like so it will be like, we will rock you, right? So that song, like, and you might be asking, oh, Sonak, you just say, we will rock you, right? There are 4, not 3. What are you talking about? But think about it. Like, if I just say, we will, we will rock you, it's not as catchy. But how did they make it catchy? They made it as in the 3 blocks, right? So they said, we will rock you, right? So that became so catchy, right? So in any sports, like, if you go, you will see people here, like, it wouldn't have been catchy if it was. And they even went a step forward, like, they mixed 2 words into one block and made the 3 blocks out of it. So they made catchy as well as rhythmic, like, it was amazing. So instead of saying, we will rock you, which is not interesting at all, now we'll have, we will rock you, right? So it's so catchy. So people tend to remember in threes. So if you can present your mental model in threes, that's the best. But it's not always possible, right? If I ask Rasu, hey Rasu, can you put the mental model of your solution for P2R application for KRISK in 3 things? She'll be like, I cannot do that, right? That's a very bad mimicry on my part, but sorry, Rasu, for me being so bad. But that's true. Like, it will be too complex to solve that problem. So it's okay to break the rules. Don't stick from today saying, oh, I need to put all my mental models in 3. Like, as we saw, even in our study, like, many of us could not fit that into 3. Like that carries P2R problem as well. Like, we could not put that into three. Like, it was so complex of a problem. It was a whole workflow with so many things. Like, we could not put our mental model into three. Actually, I tried. Like, believe me, I tried to put that thing into like three mental model blocks, but I just could not. I tried to bring the complexity down to three. I could not. But then what I did was I broke it down into 17 different components. And so all of those components, then I divided the teams into three. Like, I grouped those 17 into the groups of three. One is clinical, one is operational, one is billing. And that's how we solve the problem. Still, I tried to get into the three, but when you have too many things, it becomes very claustrophobic. Like, if I represent everything in there into one diagram, right? If I like how to make a tea, if you had like more than 13 blocks in there, then it becomes claustrophobic. It becomes non-readable, right? It becomes like people will get scared of that. So do not go beyond 13 if you're creating a flowchart, mental diagram, or system model, right? Try to stay between 3 and 8, right? Three is the best, but it takes a genius to make a three. If you can convince something in three, like, it's awesome, but it's very, very difficult. But that's okay. Break the rules. It's okay to go to four. It's okay to go to five. It's okay to go to six, seven, eight. It's completely fine. Nine, 10, 11. Okay, still people can understand, but they might miss here and there. After 13, people will not understand, because our human model, like our mind, works in a way. After 13, things will look like too messy for us. So try to remain below 13. Try to remain below 8, but more than 3. Below 3, no use, right? One or two in a system diagram does not work. But three is amazing, right? So try to put your complexity into the 3 to 8 and all that. But this power of three, I can go on with so many things. It's coming to my mind, but that's for next session. Nisha, maybe you can note down. Like, I can talk for 1 hour just on number three. Three is my favorite number. All right, but for today's session, like, we'll skip that part because we have a lot many other things to compare. But one thing that was very back to the topic, one thing that was very common on all of your solutions was your complexity. Intuitively enough, the complexity you put exactly into the range that the researchers have told. Like, they said your system model should be between 3 and 8, and most of you actually put between 3 and 8, and that's awesome. Your system model was right in there. So amazing part of that. So next thing, if you look at, is the next thing that what's common between all of this is divide and conquer. So divide and conquer is something that is very intuitive to us as well. All right. So, you guys might not have thought about that. Like, what do we do if our problem is too complex? Like in the previous example, I said, like, hey, we're doing this curious P2R project. Like, it is so complex, like with like humongous workflow with so many things, so many components. Like, if we try to solve all of those things at the same time, we will not be able to solve it. Then how do we solve it? We divide that complex problems into smaller, simpler things. Okay, break it down until it's simple enough. And we are very intuitive about it. If you find one thing that is common in all of these diagrams and videos, is you divided, even as how to make a tea is not a very difficult problem. But even that one, we were intuitive enough to break it down into simpler things. Like in this example, how to make a tea, we just broke it down into simpler things like, hey, get cup of water, add a cup of milk, and then get tea, get sugar. These are like sub problems by themselves, simpler problems. Okay, how to make a tea, I don't know, it's a complex for me, but how to get a water is a simpler thing for me. How to get milk is a simpler thing for me. How to get tea is a simpler thing for me. How to get sugar is a simpler thing for me. So we broke a complex problem of how to make a tea into the simpler things, like how to get water, milk, tea, and sugar. Awesome. And then we combined them. After solving them, we combined them into one. Okay, combine them, put in the gas, and boom, we are that. Right. So that is the whole idea, right? So divide and conquer is one of the best algorithms ever. And that comes to us very intuitively. In computer science, we do in different fashions like branch and bound, binary search tree, depth first search. Like we know how to do this in so many different ways. That's fine, but like even non-computer science majors, we know this very intuitively. Like that's how we solve problems. If your problem is too complex, break it down into simpler things. Not only professional, like even if you have a personal problem, like whatever it might be in your personal life, if your problem is too complex, please break it down into simpler ones. If you try to get bogged down into that complex problems, then you'll get frustrated. Then you might even give up on solving that problem, right? So that's one of the things that we see, like especially in the personal life. Most of the people, they cannot solve the problems. Why? Because they give up. They give up thinking, oh, the complexity of this problem is too high. Our mind, beyond 8 it's too difficult, beyond 13 is insolvable, right? So if our problem is so complex that it takes more than 13 steps to solve, then we will just give up on that, right? So do not, how to not give up then? If it's too complex, if it's going beyond 13 steps, break it down into smaller, simpler problems, and then add them up together again, and it will solve the problems. So divide and conquer is something that is very, very intuitive. All of us did that, like uh, in our healthcare workflow application that we just talked about. It's a very complex problem. So if we did not have divided into multiple different components, and trying to solve those simpler components one at a time by separate people, we would not be able to solve that problem in the time that we did. It was a too complex of a problem. So it is very important that we divide things into simpler problems. That's exactly what we do at Spiralogics. And I want to remind you all that you guys are really, really good at it. You guys are really good at it. You guys have been doing this even unknowingly, intuitively, but even at your professional or personal life, implement that. Know that, like that's what I'm saying. Like in the beginning, I said, right? You'll not be learning anything new today, but you'll only be learning the things that you already knew, right? You guys have this, then use this. If the problem is too tough, break it down, break it down, right? So, you know, when life throws you a lemon, right? So you might have learned, know this. Nisha, do you know this proverb or something? When life gives you lemon, what do you do?
Make lemon, make lemonade.
You make lemonade, right? So that's what I say. When life gives you lemon, you make lemonade, right? So we all know that. But what that proverb doesn't tell you is how to make that freaking lemonade, right? So how to make lemonade is, if life gives you lemon, cut it up, break it into smaller pieces, squeeze it up, break it into tiny, tiny things until the liquid molecules come out. That's how you make lemonade. Okay. So when life gives you lemonade, cut it into pieces, squeeze them, and then you make a lemonade. All right. So that's how you solve your problems. Divide your problems into smaller pieces and conquer each of those tiny ones. When life gives you lemon, make a lemonade by breaking that freaking lemon into tiny, tiny small pieces. All right. So what we found in common, right? So I spoke a lot about this, but one thing that we found common in all of us is every one of these pictures, diagrams, videos, and everything had nodes and links, nodes of tangible objects and links connecting those links. All of these problems had the complexity within the range, and all of these problem solvers, how they solve the problems, what they divided the complex problem into smaller ones. So all of the solutions did that. That was universally common in all of the solutions. This is how we all planned to solve our problem, to make a tea, right? So to make a tea, this is how we planned. This is called planning. This is how we planned. So this is how to make a plan or a strategy to solve a problem. We haven't made an actual tea. We put that in the paper. We made a plan about it, right? So, but this is a crucial step. And these three things, which are very, very crucial aspects of problem solving, it was common in all the solutions. So I'm so proud of you guys. You all know the basics of problem solving. You all know how to make nodes and links. You all know how to keep yourself in complexity range. You all know how to divide problem into smaller things and build them together. So this was awesome, right? So what's next? What's next? Right? So we have created our system model, right? We have created our system model. We planned our solution. We found our complexity. We, divided into smaller things and, conquered them. Great. So what's next? Like, I think we are now ready to make tea, right? We got these many solutions, these many plannings, right? Like amazing master plans. All of them have nodes and links, divide and conquer everything. We are ready to make some tea, right? But are we? Are we ready yet to make the tea? Turns out we are not ready yet, right? There's another thing that we need to do. The next part that we need to do is collaborate, like how to make things better, right? So we collected all these uh, diagrams and videos and everything from all of you, very good ideas from everywhere, but we haven't collaborated yet. All of you were doing it individually. Everyone was unique in their own way, even though we have many things in common, but none of two were like exactly same as other. Every one of them were very, very unique. But being so unique and being so different from each other, every one of those gave us, different ideas. So collaboration is a very, very important part. So after you plan, you need to learn from each other, right? We need to learn from each other. Like, I really think that, I'm best at what I do. I don't shy away from saying I'm the best. I am the best, right? But I am the best on what I know. But I accept the fact that I can get better with others' ideas, right? I might be best at what I do, but I can take Nisha's help to correct some grammars. I can take Rosina's help to make this beautiful PowerPoint slide. I did not make these slides, by the way. Rosina made it. So I'm not good at that. But if we learn from each other, we grow better. I become better from you, right? So we need to know that we need to learn from each other. I can get only better with us, right? So that's why collaboration is so, so critical. No matter how amazing you are, like I'm amazing, I'm the best, I'm super smart, but even like the work I do or the work the whole team does, the whole Spiralogics does, Spiralogics will always win than me because I will always be better than we. So collaboration is very, very important. This rapid iteration of expressing yourself, reflecting on like what things of this, and analyzing what can we learn from each other is the only way that we get clarity. So we arrange these individual solutions together, iterate through them, analyze them, and learn from them. It's the essence of design process, right? So this willingness to improve our system model, look at this, like each one of us created a individual system model of how to make tea. Now, if I have that willingness, hey, I want to improve this process of how to make tea. If I have that willingness, I want to improve this process by looking at others' ideas. That's what correlates to the improvement that we see in the overall design process. Okay, so collaboration is a very, very, very important part that we need to do after we have our individual perspective, our individual system model, right? And the next thing that we need to do is criticize. That's another thing that we miss. Is criticizing is a very important fact to make your system model better, right? We have our individual system model. We want to make it better. How do we do that? All right, I will collaborate with my friends. I'll learn from others. I'll get their better ideas, but that's not only enough. What we need to do is we need to criticize. Ideas will collide. Ideas will not match with each other. Things might get messier. Things will get messier, right? But that's okay, right? That's okay. Like, we might get conflicting ideas, might not agree to someone else's idea, might not understand why they are trying to do that. Things will start to get confusing, but that's okay. What we do is we criticize. Hey, in yours, this is not working. I think mine idea is better than this. I criticize that for that. And I criticize myself as well. That's called critical thinking. Okay, oh, I thought I would solve problem like this, but I like your idea better. Oh, maybe I can use your idea into mine to make things better. Like I criticize, oh, my idea is actually worse than yours. Okay. So criticize yourself. No problem. Criticizing is nothing to be ashamed of. Okay. So criticize others, criticize yourself. No problem. With each iteration, the model will become automatically become more clear and clearer. A unified systems model emerges eventually, right? After you keep on criticizing it at every step. you know Criticism, what it builds up is it builds up the diversity of everyone's individual points of view. That is what is supposed to be happening in our stand-up meetings, but I don't know how it goes there, but maybe not. But that's what our stand-up meetings are for, is you fight there. Hey, you guys fight with each other, you fight with the client, you fight with me, you fight with the managers. That is perfectly okay. That is actually good. If it's okay to get to disagree with what this clients say. I say many bad things about our clients, no problem. Like, Rasu says many bad things about clients, no problem. Nisha says, right? So no problem. Like, it's part of the process. Criticism is a critical part to get yourself better. But the thing is, we should be willing to criticize others. Not only that, that's the easier part, is it's easy to criticize others. We should be willing to criticize ourselves as well. We want to make our system model better. So, okay, criticize yourself as well. What did I do? Like I could have done this better, right? So it will eventually makes things better. So get your hands dirty, fight with your colleagues, not literally with your boxings or something like that, but intellectually fight with for your ideas. you know Fight with yourself, like ask yourself questions, do the critical thinking and criticize yourselves and others. That's a very important part. And the next thing that we need to do is analyze, right? That's the most important part in problem solving. Is okay, we got all these individual solutions. Someone said this, someone said this, someone said this. Like I have so many different problems, like I could not fit into one picture, but there are much more than this. But okay, we have all this. I put them in my board like this. Okay, I look at them, and what I do is now I analyze, right? So how to make a tea, that's my problem. We had our hands dirty criticizing some ideas. Okay, now it's time to analyze this, and how my thinking when I'm analyzing things are, how can I make better? Because an individual is not, like there is always something else that is better. Like as individually we tried our best, but something might have things that the other does not have, right? So how to pick the best ideas from each other and get the better selves of ourselves, right? So to do that, now let's start analyzing some of these things. First, let's take a look at this picture. Right? Really love this picture. Like very simple, but it defines this illustration defines the process very well, right? It basically says how to make a tea, right? It says collect your stuff like kettle, teacups, milk, and mix them together, tea, sugar, and then add hot water or boil, and then serve, right? So our process is very well defined. It says, hey, your process is collect, mix, boil, serve. So from this picture, this one is an awesome piece of information that I'm getting. Is, hey, how to make a tea is I need to collect stuff, I need to mix stuff, I need to boil, and I need to serve. This is what I get from this picture. So I learned from this picture. Okay, so I got something good from this picture. Now from this diagram, and but what is this missing? If you guys know, like so what is missing is like this is actually missing, like what what I'm supposed to do, like collect what, like I can figure out, maybe this is this, like and what do I mix, like how long do I boil, like like this what's and hows are not answered, right? So this is one is not completely complete for me. So, but it got a very good process flow. So I got the good part from it, good idea from this one. All right, then I get like, okay, now let me just focus on the collect part. So from the previous diagram, I just got the process saying you collect, you mix, you boil, and you serve. 4 steps, your tea is ready. But does not have any details. So for details, this is where the collaboration comes, is I need to get the help of somebody else. Now I get the help from this beautiful diagram. I really love it. And it exactly answers what I need. Like I was looking for, like, hey, the previous one says, hey, collect things, but what to collect, I don't know. But this one tells you exactly. This one even tells you exactly, like, there are two types of things that you need to collect. One are the ingredients, and one is the equipments. They are categories. Like, for the developers, they are classes, right? So they are the classes, ingredient and equipments. And what are the ingredients that we need? Water, tea, bag, and milk. And for equipments, we need kettle, cup, and spoon. So water, tea bag, and milk are the objects of class ingredients. Kettle, cup, and spoon are the objects of the class equipment, right? So it is so well defined what I need to collect, right? So this is amazing. Like this part is amazing from this chart. So I was like, oh man, this is a good idea from this diagram. I need to get this information in, and boom, I get that idea into the collect idea that I got from the previous diagram that I got. That I got the ingredients, I got the equipments. Ingredients are water, tea bags, and milks, and equipment is kettle, cup, and spoon, right? All right, I know how to collect things. Now I need to go to the mix, but I don't know how much to mix. I know I like, in the previous diagram, like, it told us like, I need water, tea bag, and milk, but like, how much water do you need? How many tea leaves do you need? How much milk do you need? How many kettles do you need? Like, those are not answered in here. It's missing in here, right? Like, it says put some water. Like, I cannot work with some. I can get better than some. It is so good in here, but it's not answering all my problems. So what do? I get help. This is the beauty of collaboration, guys. See, like, this one is not giving me the full solution. So what I do is I get the good ideas from this and I mix with the other one that gives me the same thing. It says, all right, have this one gives like answers the same specific questions from the previous slide. We know we need milk, water, tea, and sugar, but how much it was not showing, like, it was not telling me how much I needed. But this one exactly tells, have 2/3 cup of milk, 1/3 cup of water, 1 teaspoon of sugar, 2 teaspoons of tea, right? It gives me the quantities exactly. I'm like, awesome. All right, I'll get this, how to mix things from this slide, right? See how we're collaborating. We just are in like 3 or 4 diagrams that were submitted, and we are already collecting different ideas from different people. See, these are from the actual different people with their specific ideas, and we collected good parts from each of them, and our system model is already improving. We have a proper process. We know what are the things we need. We know how much of those things we need. But what we did not know is, like, in the third step it says boil, but like how long to boil, right? We don't know that. Like, but hey, somebody else answered that. See, like, collectively we are so smart. Like, the all the other guys, like, previous things, like, they represented things so well, but they missed out, like, these small things, like how long do we need to boil this thing, right? So it completely missed out. But this picture, it tells you exactly boil for 3 to 5 minutes. It even has the clock on it, and, like, amazing. Okay, so I'll get that information. Boil for 3 to 5 minutes. But is it 3 or 5? Can I get a validation onto that? Like, I don't know if it's 3 or 5. It says 3 to 5 minutes. Is it 3 minutes, 4 minutes, or 5 minutes? There are three different possibilities. So I keep on searching, I keep on analyzing, I keep on turning my papers. I have all of them printed. Like, literally, I have them printed, each one of these with me. I go through, like, each one of these, like, reading them, and I find another slide. And how long we need? 3 to 5 minutes, 3 minutes, 4 minutes, 5 minutes, I don't know. Then I find somebody else says, let it boil for 5 minutes. So I get my validation. Okay, somebody else says 3 to 5 minutes. This guy says 5 minutes. Okay, 5 minutes is it. So the termination condition for my boiling algorithm is 5 minutes. Like, until 5 minutes, keep on boiling. right? So that is a very important. Termination clause is very, very important because otherwise you'll be going forever. So my termination point is stop after 5 minutes. And I got this from a completely different solution that was given by completely different person. So this is amazing thing about collaboration. See the ideas, like each and every different people are giving from different perspectives. They are coming together and each one is answering some of the things that the other people did not answer. So collectively we are smart, right? So even the previous things, like, so the boil method is something that we need. And so okay, for boil method we'll get, from this slide we'll get an idea. Actually this was only one of the very few slides that gave emphasis on how to boil. Like everyone got it, that so intuitive. Like if I say boil it, it will just boil, but boiling requires heat and heat requires energy, right? So many of us did not think about how important a heating device is, right? So we get the boiling method from this particular uh, illustration that was submitted by some one of us. Whoever did this, amazing, man. This I love this. Like, without the gas, we could not have made tea. All right. So I get that information from here. All right. So I do that, and that's what's important, right? So what we did, like, so far. First, we had a plan, right? So we know what's in common in all of us. We had nodes and links. Our complexity was intact. Our problem solving approach was we divide into smaller pieces and we solve one at a time and conquer them. That was the planning phase. Then we started to collaborate. Then we started to criticize each other. Then we started to analyze each of these problems, right? And we got the best ideas from each of these problem solutions. And we analyzed and got the best things for us. Now this phase is called learning phase. We learned from others. We collaborated. We criticized. We analyzed. We learned. Basically, we learned from other submissions, from other ideas of solving the problems, and we learned and analyzed the problems. We do that. Now, then comes the third step is what's the outcome, right? So we planned, we learned. Now, what's the outcome, right? So that's the execution. That's like, that's where the things happen. Like till now, I'm just talking. There's no tea. It's in the paper. Like, it's literally in the paper. And we criticized, we analyzed, we collaborated, all in talkings, all in mental model. But we have not executed it yet. So what's the outcome? This is the third step. And one thing that is important is, this is where most of us fall down, is execution is actually the step that most of us get down at the first. Like when we have a problem, we immediately go into the execution stage. Like we immediately try to solve it immediately. And that's the major mistake that many of us make, right? Because if you look at it, like, without planning and learning, like, execution is very shaky, right? So execution is about all about what's the outcome, right? So we have all this information we collected, and from all the information from the nodes and links, we found, all these things. So very great stuff. Like, we collaborated, we criticized, we analyzed all of these things, and we got the best ideas from here. Now, I even have the best idea. I have the system model. I have the best ideas from all those system models. Now it's time to implement. How do I implement this thing? Right? So during the implementation, the first thing that comes in are the data structures, right? So data structures, like, for many of us who are developers here, it's like piece of cake for us. But, but for others also, it's very intuitive. It's basically how we organize information, right? So we have like bunch of information collected from so many different places. uh, it's very important. Information is a very crucial part in any problem solving activities, right? Without information, no objective can be reached, right? It's very important that we organize the information in such a way that it's very easy to access the most efficient way possible. That is all about data structure is, I have so much of information. How do I get in the most efficient way possible? Right. So from our previous analysis and planning, we know that there are two main components that we need as data. One is the equipment, one is the ingredients. We know that kettle, so we define them into two separate classes as equipments and ingredients. We can add them as separate objects, like kettle is of 1 liter, cup is of 3 liters, spoon is 16 ounce, ingredients, water is like 0.67 of a cup, because we got 2/3 from one of those diagrams, right? 1/3 is 0.33 milk, tea leaves is 2 spoons, sugar is 1 spoons, right? So we arrange all this information like two one, like 2/3, 1/3, 1 liter, 3 liters, all this information that we got from our system model, we organize them into the data structure, right? Now data structure is not complete like until we find out the what is the best way. So for this problem, right, I'm going to make a tea, right? I'm in the kitchen. If I'm going to make a tea, what is the most important thing? Like, these are all things I need. I need kettle, cup, spoon, and all that. So what is the most important thing to access is the fastest way possible, right? So basically it means like, I need to grab my kettle very quick. I need to grab like, hey, if milk is there, get the milk quick, right? So it will be fastest way possible is what we need. So for that one, so let's think about it. Like, order is not important. Like, water comes first or meal comes first, doesn't matter, right? But if we put them in the stack, like, if we put them, okay, here is water, here is milk, here is tea leaves, here is sugar, here is kettle, here is cup, here is spoon, like, then the order is like, first one is milk and so on, like order is preserved. But to get milk, I have to go through, oh, the first one, is this milk? No, it's kettle. Okay, second one, is this milk? No, it's cup. Third one, is this spoon? No, it's spoon. I have to go through like all 7 steps just to find my milk, right? So it's not very efficient. So how do we make it efficient is from the data structure. So we know that one thing that is common is all of these have key values, right? So so like all the equipments like kettle, we know that kettle is like a kettle of 1 liters, like they have certain values in there. But if we organize them in a hash map, right? So we give them an index. So, for non-developers, so a hash map is basically key value here. Here's a key, here's a value, right? If it's Saunak, I will represent Saunak as a hash code, like Saunak is 1. So it's very easy to find Saunak very quickly. Like if I have a hash map, I can find kettle in 1 step. Whereas if I put in a list, I will need like n steps to find it. So HasMap is very efficient. That's how actually our CPUs work. That's how you can use your computer so fast and looking at this screens just because like, we are smart enough to give CPUs this smart data structure that they can take so quickly, right? With the hash map, we can take in 1 step, you can get what you need. So for our tea making plan, like, okay, we got all the information, we have our data, how we structured it, like let's structure into hash map or hash table. Which one is better? Like, but that's too technical, but it's for developers. They know the answer. Like, if you don't know, go back and read. Okay. But go back to your school. But like, we know, like, hashing structure helps very much for this kind of data structure where we need to find something very, very quickly. Right. So we create these data structures. Right. So that's a very important part of it. Then we come into algorithms, right? So algorithm is, you know, it's very simple. It's basically a set of instructions that we derived from our previous system model. All of us created system model, right? It's your ideas that you put in the paper. What I did was got all of your ideas, collaborated them, analyzed them, get the best ones from each of them. And after all that, now it's time to implement or execute. Now, what I do is I put the same thing into the algorithm, basically step-by-step instructions of how to solve a problem, right? And from your submissions, I already know it's, basically 4 steps that we know was common in all the steps, right? All the diagrams. The first thing is collect, right? So we want to collect our equipments like kettle, cup, and spoon, right? And we want to collect our ingredients like water, milk, tea, and sugar, right? So this is what we want to collect. Now, if you look, algorithm is basically set of instructions: get equipment, get ingredients. That's all algorithm is. And believe it or not, all the projects that we did in Spiralogics, or all the things like Google, Facebook, whatever you guys use, everything is just this bottom line. They are just set of instructions put on top of each other until we give a complete solutions. And we use divide and conquer. So we are solving a very simple problem first, right? We divided the bigger problem of how to make tea into smaller problems, right? Like let's collect our equipments and ingredients. So this one was a smaller problem, and I put the set of instruction. This is an algorithm by itself. Okay, so one problem solved. We divided the bigger problem into four problems, and one problem is solved. We know how to collect. Then we go into the mix. Now we know how to mix. So from the previous data structures and analysis, we know that using the cup and spoon, we need to add milk, tea leaves, sugar to the kettle in the specified amounts, right? And what are those amounts? We get from our hash map or hash table. Again, developers figure it out. Is it hash map or hash table? All right, but anyways, so we get, right, and we mix them up. So this is the second algorithm. So this one, so so data structures are the builders of the algorithm. Algorithms cannot stand by themselves without the proper data structures. All right. So we got the second problem, that is how we mix it. All right. Then we have this simple algorithm in there. All we got to do is add this to get correct, right? So this is an algorithm by itself. This is an algorithm by itself. Divide and conquer, guys. Divide and conquer. All right. And then we go into the third problem that we did was boil, right? We need to boil, right? So we need a set of instructions for this problem, right? So we are solving simpler problems one at a time, divide and conquer. So for boil, okay, what do? We get the gas stove from equipment. So we have a data structure for equipments. So we get the gas stove from there, right? So great. So from the hash map of equipment, we get the gas stove. We put the kettle on the gas stove. Kettle is also a data that we got from the data structure. Gas stove is also the data that we got from the equipment, right? So we put the kettle on the gas stove. We turn on the gas stove to provide energy, of course. So turn on, it's an instruction. So, again, algorithm is are just these instructions: get, put, turn on, right? Then we need to wait, like while elapsed time is less than 5 minutes, leave the heat on. So basically we are saying, keep on boiling that thing until we pass 5 minutes timeline. If it's less than five, keep on boiling that thing. All right. That's also we got from, previous examples that we saw. And after 5 minutes, turn off the gas stove, right? So this solves this one problem of boiling, right? So we solve three simple problems: collect, mix, boil. All right. And then finally, we serve. We get the serving cutlery from equipment. We pour the tea from the kettle to the serving cup, and then we enjoy our tea. All right. So we solve this problem as well. So we are solving collect problem, mix problem, boil problem, serve problem. We are creating the algorithms for collect. We are solving the algorithm for mix. We are solving the algorithm for boil. We are solving the algorithm for serve. And after we divide, we combine all them together, and all of them come together as an algorithm on how to make a tea. This completes us, right? So divide and conquer, right? Make algorithms for the simpler things, add them together to achieve greater problems, to solve greater problems. And this is how we solve problems. And this is not something that is fancy or I invented or nothing. All of us knew that. As I told you in the very beginning of the presentation, I did not talk anything new or fancy today. All I was talking are the things that you guys already know. I was talking about the things that you guys did yourself, right? So you guys learned nothing new. Only thing that you guys learned is how we put things together and what those things are. It's important for us to know our own capabilities. All of us are capable of doing this, and it's very important for solving problems in your personal as well as professional life. Like this might be a simple example on how to make a tea, but it can be applied equally as how to create a healthcare workflow system in our work, or it can be as equally applied to a problem in the personal life, like my girlfriend broke up with me, what do I do? Same thing. How to make a tea, how to create the advanced complex workflow algorithm, what do I do after my girlfriend breaks up with me? All of them are problems, and the way of solving them are exactly the same. Okay, so how do we solve those problems, right? The whole thing that we talk about is how in the world we solve those problems, be it professional, be it personal. Like, how do we solve the problem? How I tell you, let me reiterate one thing again, right? This is nothing new. This is not the magic formula. This is not like, Sonak's divine knowledge sharing or anything. This is something I learned from you. This is something that you guys already know how to do, but I'm just reiterating, revising the things that you already know, right? So how you solve a problem is first you plan. Plan for solving problems. Do not jump on solving problems right away without planning for it. Plan. Many of us miss that, right? So that's the important part. Not miss planning. Planning is very, very important. Now, how do we plan? We create our system design. Draw. Put your mental thinking or mental perspective into paper. Draw into the simple uh, you know system model, just nodes and links. We know how to draw. You just create a system design. That's system design. So you create the system design, and then you measure the complexity. Just then you think, hey, is it too complex? If it takes more than 13 steps to solve my problem, then it's too complex. Even if it takes more than 8, then it's too complex, right? So we say, okay, I want to stay within the complexity. Like if I can, I try to solve my problem in 3 steps. 3 is a magic number. Again, I'm mesmerized by 3. But anyways, uh, complexity. You measure the complexity. Am I within the complexity? If it's too complex, complexity is above that, then you divide and conquer. So you divide your problem into smaller problems. Then you iterate through the same thing again. You design the system design. You do the system design for those simpler problems, measure the complexity. Hey, if this thing is still complex, then you still do divide and conquer. You divide further down. You do the system design, measure the complexity. Is it too complex? If it complex, divide and conquer. You keep on dividing and conquering until you reach to the like simpler things that is simple enough for you to fix. Because if you go and head on to solve a problem that is too complex for you to solve, then you'll get frustrated. You might just give up. So the way you do it is you create a system model, check the complexity, too complex, divide. Too complex, divide. Keep on dividing until you're confident, oh, this is simple enough for me to solve. Then you keep on adding them, then the problem gets solved. So great. So how you solve a problem is number one step is you plan. Okay. You plan first. How you plan is you create a system design, you measure your complexity. If the too complex, divide those problems into simpler problems and conquer them. All right. So after we plan, what do? We learn. It's very important stuff. Many people, even if they plan, what they do is they plan, oh, I want to solve the problem in this way. What they do is they jump immediately into the execution. They will say, oh, I have a problem. Oh, I have this bug in this program. Oh, client reported this issue. So that's the problem. Then I plan, oh, this is the issue. Okay, this is how it caused. I'll solve it this way. Okay, you have a plan. Then you immediately go coding or you immediately go solving the problem. In personal life, maybe the same thing happens. You plan and you immediately go solving problem. You go directly to the execution. But no, wait, just give a second thought. Like learn is a very important phase. It's very, very important because after you plan, you got to learn. So how do you learn? Is collaborate. Like, maybe ask others, hey, you have any idea, like, how to solve this problem? Maybe they have better ideas or something. Or collaborate with yourself, like criticize yourself, right? So other one criticize is criticize yourself, like, okay, my plan is to do this, but doing this, will it solve? Is there a better way? Like, I did something stupid or some. Criticize yourself or criticize others. Don't shy away from criticize. Criticizing is a way to learn. All right. And then we analyze. That's the most important part is you analyze your plan before execution. Always analyze like what are the best ideas? Where can I get the best ideas? Like if there are two conflicting ideas, which one is better? How can I make things better? Right? Like what I can get from somebody else, analyze from different places. So collaborate, criticize, analyze. These three things will help you learn. So how you solve a problem, you plan first, then you learn. How you learn, you collaborate first, you criticize first, and then analyze, right? And then the final one is after that you execute. Is you know, do not jump into this thing implementation immediately, right? After, if you plan something well, if you learn things well, execution becomes the easiest part. It might be the longest part because some problems might take time to solve. Okay, that's fine. But it will become the easiest part if you plan or learn properly, right? So you execute your plan from the things that you have learned from. Now, how you execute is you divide into things like, where are my information, data structures, right? Where is my data? Where is my information? Gather as much information as you can and organize them in the best way possible. Organize in the way that you can, clearly, visibly, visualize it, right? So the data structures are the main important things when executing. Then comes the algorithms, right? Give a set of step-by-step instructions on how to solve that problems utilizing the pillars of the data structures. So you write those step-by-step instructions to solve that problem in coding, but like in real life, you execute or you behave those step-by-step instructions that you give to yourself or somebody else, like you just follow the steps. Same thing, guys, right? Nothing else. And what happens is then you implement utilizing these data structures and algorithm. You go to the field and you solve your problem, right? You start implementing. Okay, data structures give me this. I put in this step, get this, put this step, get this, put this step, and then we execute. So we plan, we learn, and then we execute. So what happens? This cycle keeps on going forever. All right. So always think, how do you solve a problem? So to solve a problem, always think in these three steps. Is plan things first. You draw your system model, like think like how to solve it. Try to be as minimal as possible. Do not bombard yourself with like whole lot of things to do, and then check the complexity, like, hey, too complex or not. If it's too complex, divide into simpler problems and repeat the cycle. Then you learn, collaborate, criticize, analyze. Then you execute using having proper information, putting step-by-step instructions and combining those two to execute your problem. And this is how you solve any problem, both problems solving at Spiralogics, at work, personal life, or anything. And this is something that we all know. Plan, learn, execute. Plan, learn, execute, right? So we just keep on doing that completely on that. And guys, right? So this is how finally you make a cup of tea. All right. So I hope you guys learned finally something like, that we finally learned how to make a tea, right? So with this algorithm that we just devised from all of your ideas, small things from here and there, with our proper planning, analyzing, and all that, like we have a proper algorithm now to create a tea. All we need now is a rich investor and someone with C++ coding knowledge. Then we can create our own automated tea machine that we can put up in Spiralogics, right? Use that algorithm and create that tea machine and put it up there, and you can enjoy your tea every other day. So you guys solve that problems yourself. Implement the same things everywhere, professional life. And that is how you make a cup of tea, guys. And that is how you solve the problems in your ways. And I learned a lot from all of you guys. Thank you so much for all of their submissions, great ideas and great things that you put in place. And I'm amazed by what you can do, and just believe in yourself. Like, you guys know how to do all of those things. And today's session is just about that. You learned nothing new, but you learned what you already knew. Thank you so much, guys, and have a great day. Thank you.